Right, this is your lesson on complex numbers. You will use the I to write complex numbers. And you will add, subtract, or multiply complex numbers. And use complex conjugates to write the quotient of two complex numbers in standard form. You will also learn to plot them on a complex plane. The definition of a complex number or imaginary number, the definition of an imaginary number is I is equal to the square root of -1. For the longest time, we could not do a lot of math because we could not take the square root of a negative number because they were not real. So we had to fake it by creating this imaginary unit, what we call I. And this made it possible for us to have computers. And with computers now you have your smartphones and your tablets and your iPads and your iPhones and like the computer that you are watching this video on right now is because we've invented the imaginary unit. Okay, so that's why it's very important. And it's really not that hard. It just sounds difficult because it's not real. Alright, first we're going to look at what happens when we take the imaginary unit to an exponent. Well, I to the 1 is just I. And if we square I, basically what I'm telling you to do, if we square this side and this side, we can cancel out the square root. So that means that I squared is going to equal -1. And I to the third would be square root of -1 times square root of -1 times square root of -1. Or we're going to just multiply these two, right? I to the second times I to the 1 is I to the third. So that would just be -1 times I, which is -I. And I to the fourth will just be I squared times I squared. So that would be -1 times -1, which just gives me 1. What about I to the fifth? I to the fifth would be I to the fourth times I to the first, which would be 1 times I, which is just 1I. And I to the sixth would be I to the fourth times I squared is -I, or -1. 1 times -1 is -1. And then I to the seventh is I to the fourth times I to the third, which is 1 times -I, which is -I again. And I to the eighth is I to the fourth times I to the fourth, which is 1 times 1, which is 1. I to the ninth. Well, that would be I to the eighth times I to the first, which is 1 times I, which is 1I. I am hoping that you're starting to see a pattern here. That I to the 10th is, let's see, I to the 8th times I squared, which is 1 times -1, should be -1. And so on. So what do you think, looking at these patterns here, what do you think this one will be here? How about I to the third times I to the 8th? So that will be -I. Or if you're really looking at the pattern, you see that I, -1, -I, 1, they just keep repeating this pattern every 4 times. So this one better be 1. So after every 4, you notice it repeats, right? So, in other words, you can take I to the 8th and subtract 4 and you'll get this. I to the 12th, subtract 4 and you'll get 1. Subtract 4 again, you'll get 1. I to the 11th, subtract 4, you'll get I to the 7th, subtract 4, you'll get I to the 3rd. And if you take 10 minus 4, you get 6, minus 4, you get 2. So if you memorize this right here, these 4, all you have to do is start subtracting by 4 multiple times. Well, multiple subtraction is just division. So if you take 12 divided by 4, you'll just have 4 3 times. So this has to be the same. And if you take 11 and you divide by 4, it goes into 11 twice with 3 left over. 10 divided by 4 goes in there twice with a remainder of 2. So you can take any number of the exponent divided by 4, whatever the remainder is, it will be one of these. So it would be I to the 21st. Well, I goes into 21 5 times with a remainder of 1. So the I to the 21st power is just I to the 1, which is I. How about I to the 102? Well, 4 goes into 100 25 times with 2 left over, so it would just be this one right here. See if you know what this is. I to the 19th. 19 divided by 4 goes in there 6 times with 3 left over. 3 left over is negative I. What about 29? 29 divided by 4 goes into there 7 times with 1 left over. 1 left over is just I. 39 divided by 4. 4 goes into 39. Let's see, I believe 36 is the closest you can get with 3 left over. 3 left over is negative I again. What about 46? Divided by 4 goes into there 11 times 44. 2 left over. 2 left over is I squared. I squared is just negative 1. Okay. Now let's talk about a complex number. We just talked about imaginary numbers. Complex number is just a real number plus imaginary number. Like negative 4 is a real number and 3i is an imaginary number. You put them together and you're going to get a complex number. Okay. Standard form for a complex number is just the real part, which we call a, and the imaginary part, which is just bi. Okay, some number, some coefficient times I. There's your real part, your imaginary part. Write this number in standard form. So standard form is just the real part first and plus the imaginary part. So how do we do this? We would distribute the negative 2 to the 1, so we'll get negative 2, and negative 2 times 3i will give me a negative 6i. Negative 6i plus 2i would give me negative 4i. So that's how you use standard form. The real part and then the imaginary part. Graphing. Graphing, just think of the real axis is the x-axis and the y-axis is the imaginary axis. So this would be a negative 2 on the real axis and a negative 4 on the imaginary axis. So this would be 2 on the x-axis and then negative 2 on the x-axis and negative 4 on the y-axis. So that this point right here represents negative 2, comma, negative 4. That's all. That's how you do that. Adding and subtracting complex numbers. Basically, you're just adding up all the like terms. Just that when you're subtracting, make sure you distribute the negative sign. So if you add up all the like terms here, you're going to add the 3 and the 2 and the 7 plus the and 4 plus the negative 7, and you should get 5 minus 3i. Okay, on this one, you would collect your like terms. 1 minus 3, negative 2, and 7 plus 2, which is 9, minus a negative 4, which gives you positive 13i. Do this one on your own. See if you can get the right answer. Pause it. This is 4 minus 7 is negative 3. 3 minus 1 is 2 minus another 1. There's just 1i. Okay. Multiplying complex numbers. You multiply, you're going to get 4 times 16, which is 64, and I times I, which is I squared. But I squared is negative 1, so this will be negative 64. How about this one? Okay, we take the square root of this and take the square of that, and we get negative 1 times 25 times negative 1 times 9. I can take the square root of the 25 and get 5, take the square root of 9 and get 3, and then this is just I and I. So this is 15i squared, and I squared is a negative 1. That's negative 15. Foiling this out, we get 2 times 4 is 8. 2 times negative I is negative 2i. 3i times 4 is positive 12i. And 3i times negative 1 is negative 3i squared. And I know that the I squared is a negative 1, so that makes that a positive 3. Combine my negative 2 plus the 12 is 10i. And combining my 3 and my 8 gives me 11i plus 10i. 11 plus 10i. You want to try this one on your own? See if you can come up with the right answer. Pause it, and then come back and look at it. Okay, this is going to give me 28i minus 12i squared. But the I squared is negative 1, which makes this a positive 12i, or 12, plus 28i. One more. Squaring this. Okay, remember this has to be FOILed out. You can't just square each term in here. So foiling this out, you get 2 times 2 is 4. 2 times 3i is 6i. 3i times 2 is another 6i. And 3i times 3i is 9i squared. This gives me 12i minus 9 because I squared the I and got a negative 1. Combining my like terms, so negative 5 plus 12i. Multiplying by conjugate. So if it's 3 minus 7i, the conjugate would be 3 plus 7i. There's, okay, when we FOIL this out, we're going to get 3 squared minus 7i squared. That's just a difference of squares. So this is 9 minus 49i squared, and we know that I squared is a negative 1, so this is going to be plus 49, and final answer is 58. Now you think about this, a difference of squares is always going to be minus here, and it's always going to have an I squared, so this is going to be always a plus here. So you're multiplying by a conjugate, you can just square them and add them together. 3 squared plus 7 squared, add them together, you should get 58. What about 1 plus 5i? How would you multiply that by the conjugate? Well, that would be 1 minus 5i. So then this will be 1 squared plus 5i squared. This will be 1 minus 25i squared, which is 1 plus 25, or just 26. You notice that when we multiply a complex number by its conjugate, we get a real number. There's no more complex number, no more imaginaries. And that is a little trick that we're going to use later on when we want to get rid of the imaginary, we multiply by its conjugate. Okay, one more. 2 minus I. The conjugate is 2 plus I. You want to try and finish this, you should pause it. Okay. What did you get? That's 4 plus 1, which is 5. Okay. Now write the quotient in standard form. Standard form is you're going to have a real number plus imaginary number, a plus bi. How do I get rid of this denominator? We can't have an imaginary number in the denominator, just like we can't have a square root in the denominator. Well, we just multiplied by the conjugate to get rid of, to turn a complex number into a real number, so let's do that. We're going to multiply by the conjugate of the denominator because we're worried about the I in the denominator. We don't care about the I in the numerator. So we're going to multiply by 3 plus 4i on the top and the bottom, in the numerator and the denominator. We do have to FOIL this out on both places. We need to FOIL this out on top. We get a negative 12 because this is 12 times I squared. And then we get a 9i and an 8i. We add those together. Remember my little trick here, you just square both of these and add them together, because when you square the I, you get a negative. Combining all that together, we get negative 6 plus 17i over 25. And this is pretty much done, except we do like to write our real part first plus our imaginary part. This makes it easy for us to use it if we're going to use it in another step. This makes it easier for us to graph it if we have to graph it. Okay, so okay, try this last thing here, and then we're going to be done. On your own, pause it, see if you can come up with the right answer. Okay, you're going to multiply by the conjugate of the denominator, which is 1 minus 2i. FOIL it all out. Combine your like terms. And then just separate them into the real part and the imaginary part. And that's your final answer. Okay, don't forget your Google form. That's it.